Function. Previously, we knew about a function that must be created so that our program can run, namely the main function. A function is a block of code that is deliberately created in a program so that it can be used repeatedly. The way to create a function is very simple. Just use the keyword func, followed by the name of the function and the code block containing the function. After creating a function, we can execute the function by calling it using the function name keyword followed by an opening parenthesis, a closing parenthesis. In this scenario, we create a simple function named sayHello in the Go programming language. The purpose of this function is to print the message hello. The function is then invoked within the main function of the program. Function parameter. When creating a function, sometimes we need external data, or what we call parameters. We can add parameters to the function, maybe more than one. Parameters are not mandatory, so we can create a function without parameters like we previously created. However, if we add parameters to a function, then when calling the function, we must enter data into the parameters. In this example, we create a function named add in the Go programming language, which takes two input parameters, namely x and I, both of type integer. Inside the add function, the operation of adding the two input parameters is executed, and the result is then printed. Subsequently, this add function is invoked within the main function of the program. Function return value. Functions can return data. To tell that a function returns data, we have to write down the return data type of the function. If we declare the function with a return data type, then in the function we must return data. To return data from a function, we can use the return keyword followed by the data. In this example, we define a function named addReturn in the Go programming language. The function takes two input parameters, x and y, both of type integer, and it returns an integer value. Within the addReturn function, an addition operation is performed on the input parameters x and y, and the result is then returned. Subsequently, this addReturn function is called within the main function of the program. Returning multiple values. Functions can not only return one value, but also multiple values. To tell if a function returns multiple values, we have to write all the return value data types in the function. In this example, we create a function named rectangle in the Go programming language, which takes two input parameters, x and y, both of type integer. The function is designed to have two return values, namely area and parameter, both of type integer. Inside the rectangle function, an addition operation is performed on the input parameters x and y to calculate the area and perimeter of a rectangle. The computed results are then returned as multiple values. Subsequently, the rectangle function is called within the main function of the program. Ignoring return value. Multiple return value must capture all its values. If we want to ignore the return value, we can use the sign _. In this example, we create a function named getFullName in the Go programming language, which is designed to have two return values of type string. The function, when invoked, returns two strings, John and David. Subsequently, The getFullName function is called within the main function of the program. To test it, we define a parameter named firstName and use an underscore to discard the second returned string. Finally, we print the result. Named return values. Usually when we say that a function returns a value, we only declare the return value data type in the function. However, we can also create variables directly in the return function data type. In this example, we define a function named getCompleterName in the Go programming language, structured to have two return values, both of type string. Within the getCompleterName function, the operation is simple, returning two strings, John and David. Subsequently, the getCompleteName function is invoked within the main function of the program. To test it, we create parameters named firstName and lastName. Finally, we print the result. Function as parameter. We can not only store functions in variables as values, but we can also use it as a parameter for other functions. In this example, we create a function named getHelloWithFilter in the Go programming language, which takes two input parameters. The first parameter, name, represents a name, and the second parameter, filter, is a function. Inside the function, the provided filter function is executed, modifying the input name based on certain conditions. Specifically, we define a sample filter named spamFilter, which checks if the input name is equal to dog. If true, it returns the string dot, and if false, it returns the original name. This getHelloWithFilter function is then called within the main function of the program. Now it's time for us to print to see the results. Number 1. Write a function called rectangleInfo that takes the length and width of a rectangle as parameters and returns the area and perimeter with named return values. Number 2. Write a function called counterWithState that returns a closure. The closure should maintain a counter variable and also accept an increment value as a parameter. Number 3. Write a function called processNumbers that takes a slice of integers and a callback function. Apply the callback function to each element of the slice. In addressing exercise number 1, we create a function named rectangleInfo in the Go programming language. This function takes two input parameters, length and width, both of type float64, and returns two values, area and perimeter. Inside the function, calculations for the area and perimeter are performed, and the results are then returned. The rectangleInfo function is invoked with the input values 4 and 5, and the obtained results are printed. Moving on to exercise number 2, we craft a function called counterWithState. This function has a return value of integer and includes an inner function named increment. Within the increment function, an increment operation is performed, and the function itself is returned, creating a loop where the count continuously increases. The counterWithState function is called with various input values, such as 2, 3, and 5, and the results are printed. Finally, addressing the last question, the initial step involves creating a function named processNumber that takes a slice and a callback function as input. Inside the function, a loop iterates over the input numbers, applying the callback function to each element and printing the results. To test the first function, a slice containing integers from 1 to 5 is created. The process number function is then called with the created slice and a callback function that performs multiplication on the input. The results are observed by executing the code. Now it's time for us to print to see the results.